Yesterday, we talked about 3 congruent triangle theorems. Today, I'm adding 2 more. ASA. What do you think? Okay, so if 2 angles and the included side of one triangle is congruent He's scraping up the pencil shavings. Okay, 2 angles and an included side congruent to 2 angles and an included side of a second triangle. That's probably good, buddy. That's probably good. Oh, okay, Charles. Okay, so if we're gonna, thank you. If we're gonna use angle side angle, then we need 2 angles and the included, bless you, side. Angle side angle. Sorry, I really need more water. Okay, so now, what's going to change for angle side? So 2 angles and a non-included side. Bless you. Okay, so what I want you to do is I want you to look down below, and with your elbow partner, I want you to decide of those 4 pictures which ones are congruent and by which theorem. Just gonna hide.
I would like that thing to be moved. It's horrifying.
Sorry.
Can I switch seats with you? No. My best boy. Here, you can lean him on. Oh, what am I? This would be
Oh wait.
The only thing we can say is true is how do you know if it's say or is number 2 possible?
So is the side in between the 2 angles or not? So do you see how like this side is in between the 2 angles, but this side is not?
Are these?
Wait, so does this?
Yeah?
Wait, so
Can we prove that? Angle.
does that?
Is that one we've talked about?
No, so,
angle slide.
wait, so what would this one be?
So we
A.
can't prove it?
What would this one be?
Angle, angle, The side will not be in between.
Oh, I would not be.
Josh, you're leading me down the wrong path.
Since the two angles like match, could we just
Nope.
put the tick marks?
No.
Wait. No, it's not.
Oh, if
That's only one
possible. Oh, if
The
possible.
second one is not possible.
Ah.
Now you can because they're both sets of congruent or parallel lines. Yeah. Gonna give you one more minute.
This one's ASA. No, it's ASA. This one's not ASA. It's ASA. The last one's ASA.
Where's the other one? Where's the other one?
All right. In this first one, that kind of looks like, okay, interesting. We have lots of interpretations. Okay, is there anything that we can mark?
Yes. That line.
That middle one. That middle one, yeah.
The reflexive side? Okay, so this is two angles and a side that's not included. Okay. Is there anything we can mark here?
Vertical.
Okay.
Would that be AAA?
Okay. The only thing we know about angle, angle, angle is our triangles would be proportional. But if we don't know anything about a side, there's nothing that we can do. Okay? So we don't have enough information to prove that those are congruent.
Yeah. I think this one's also.
Okay? Three angles being congruent to three angles only tells us that the triangles are similar, they're proportional, but it gives us nothing else. Okay? Now, here, nothing is marked except parallel lines. So, parallel line, transversal parallel line tells us that these are congruent angles. Parallel line, transversal parallel line tells us that these are congruent. And then we have the reflexive property. So I'm hoping that you said yes, ASA. Yeah. Okay. Eventually, we got there, okay? Hey, we're just starting. Okay, and then this picture, we have the reflexive property. Is there anything else? Oh, cool, two sides and an angle. We cannot do angle, side, side.
I just figured that. It's none.
You just figured out why I keep saying bad words aren't allowed?
No.
Oh, got it. Okay. All right, here we go. So let's do some proofs. Honestly, people, this is not going to be much different than yesterday. Okay? Okay, number one, write the given.
Oh, I see.
SQ bisects two different angles. If I have a segment bisecting an angle, what kind of congruent statement are we going to be able to write? What, angles or sides? Okay, SQ is bisecting an angle. Two different angles, okay? So if we start with SQ is bisecting RQT, then that means that these two angles right here are congruent. Angle RQT is RQS. RQS is congruent to angle TQS.
Could we do SQ and then the reflexive property?
Well, so SQ is bisecting two different angles. So SQ bisecting RST is this.
So another dimension of bicycle.
Yes. Sorry, I had to relay a message. Okay, now we have two angles that are congruent. Our third piece of information will be,
QS congruent to QS.
all right,
Reflexive property.
okay. QS is congruent to itself because of the reflexive property. I have three pieces of information. I've also marked my diagram so I can visualize where my three pieces of information are. It looks like that I now can say these two triangles are congruent by angle side angle. Those three pieces of information match angle side angle. Okay. No, I will never have. What?
The abbreviation for the next one.
I know, right? It's pretty cool. All right, let's go ahead and go to the next page. I really like this one. It's not long. Oh, well, that's after Thanksgiving. Okay, pick a color from that color block right there. Okay. Angle ABC is congruent to angle CED. ABC, CED. Okay. Oh, that's an angle, right? That was so nice of them. Okay. We also have AB parallel to CE. AB is parallel to CE. And C is the midpoint of AD. Okay, so we have three pieces of given information. One piece is already giving us congruent angles. Thank you. So now, yes?
If one angle is the same as two other angles, how do you write that?
What? Okay, so let's go to our parallel lines. Okay, the Z is not going to help us this time. Okay, so this is what I'm going to do. Parallel lines, transversal. It's not the Z that's going to help us. Okay, so that's not the transversal that's going to help us. Let's look at this one. Parallel line, transversal. What do you see? Oh, do you see? What are those? Corresponding. Angle BAC and angle ECD are congruent because of the corresponding angles theorem. Okay, that's why I like this one, so we could see our parallel lines using just like a different type of angle. Okay. Okay, what about the midpoint? What can that do for us? Because definition of midpoint. Step ahead of me, buddy. Okay, we are not going to write angle, angle, side until we talk about the triangles being congruent. Okay, now we have 3 pieces of given information. One of them already was a set of angles. One of them we used to get this angle. The other one we used to get this pair of sides. Okay, we've used all the given information. There's nothing else that we need to mark. Okay, now we can say triangle ABC is congruent to triangle CED, and this is when we say AAS. Are you okay? Okay. You're just like giving me the evil eye. Ungraded worksheet. Okay. So you will have plenty of time to work on your worksheet because we're just going to do one more proof. Okay. Okay, write in your given and mark up your diagram. Corbin, you are unnecessarily being... I don't even know what to say right now. All right. Here's the deal. There's probably 3 different ways we can go about writing this proof.
Oh, I see it.
Okay. There's some parallel lines that can help us. Yes, I see some vertical angles. Okay. So it kind of depends on how you want to go about it. Okay. So if LG and JM are parallel, this is what I know as parallel line, transversal parallel line. Okay, so which 2 angles? Guess what, guys? We can just say J and G. That's a G, sorry, and a J. Since they're the only angles at that vertex, we can do that. All right, there's one angle. We can do the midpoint. Okay, if H is the midpoint of LM, LH is congruent to HM. Definition of midpoint. Okay. Now we've used both pieces of given information. Now let's talk about that vertical angle. Okay. Can we call that angle H? No, because we have more than one angle at that vertex. Now I have to call it LHG. And that was supposed to be an L. Thank you. LHG MHJ. Okay. So now I have my 3 pieces of information. So I can say that my 2 triangles, my goodness, are congruent by which theorem? Angle, angle, side.